Okay, what is the idea? What is the idea? What is the idea? Let me explain at the beginning. At the beginning is we have an object. That object, okay, this is too hot. And this object have initial temperature. Okay, in our problem, okay, we have here to the left, the initial is 100 Celsius degree. Look at that, this guy. And so you left this object in one room. It has different temperatures final, temperature of the room. You left here 24 hours maybe. Today, 1 years. Es obvio que the heat is transferred from the object to the environment, and the temperature final in the object is the same of the temperature of the room. But the formula is, in this case, 30 degree. Look, 30 degree is the temperature final. However, give me two temperatures. I want to call temperature 1 and temperature 2. And the temperature 1 is using to find the K. And remember to define exponential. So we have a family of the exponential, right? However, specifically, the curve que corresponde of our problem is determined by the K. K is a constant of decay in this case, decay, because it's decreasing. And it's given temperature 1 at the time 1, okay, 5 minutes, okay? However, I want to investigate another temperature, okay, of course is smaller, how long is the time I need to wait to decrease in the temperature to 50, no? To 50 degrees. And this is the formula. And this is the formula. So the formula is use substitution. Our specific condition 0 is given everything. Condition 0 is well, temper final is 30. So my formula is a specific formula for that problem is temperature to any time is equal to 30 is the final temperature plus initial get 100 minus 30 get 70 e to the KT. Actually, let me do simplification a little bit. This is 30 plus 70 exponential KT. This is our formula. Specific for the condition 0 of the our problem. Condition 0. Now using the condition 1, because in the condition 1 everything is given. It's given the temperature. It's given the time in this condition. So we have on everything except K. So this condition 1 allow me find the K value. Que es the constant of the exponential que decreasing the exponential. Entonces, 80 degree is the temperature at this minute. What is 80 degree? It's temperature at 5. Evaluate at 5 what? At 5 minutes. Is equal 30 plus 70 e to the K times 5. Because the time is 5. The time is measured depending on the problem in minutes, in seconds, or in hours, or in years, no? Now, you know, another example that we are doing before. Now, we are doing something in order to isolate the K. And we expect, when you finish the problem, K is negative value because it's decay exponential, no? Okay, no, it's easy. You subtracting 80 minus 30, okay, 50. Is equal to 70 exponential 5K. I put the coefficients in the first place. Now divided by 7 in both sides. You of course cancel out this 0. Is 5 over 7 is equal exponential 5K. Now it's a clear exponential equation. And the best way is apply natural logarithm, the logarithm is the same base of the exponential. Therefore, undoes each other. You know that property. Now, logarithm of 5 over 7 divided by is equal 5k, no? Because logarithm and exponential undoes each other. Therefore, k alone is natural logarithm of 5 over 7 divided by 5. You can put in the calculator if you want this quantity or no. It's up to you. I forgot my one. Okay. No word for this. You put in the calculator, of course, you get negative value. Why? How do you know? Well, you put in the calculator, you see negative, but without calculator, it's negative because the argument inside the logarithm is a number less than 1. In what situation happen, and the base is greater than 1, entonces es obvio que es negative exponent, no? However, well, in order to find, remember, we have the temperature 2 for the condition 2, and the temperature 2 is 50 degrees Celsius. Now I need to find how long, so what is the time in which the object have 50 degree temperature in its temperature. Okay, so now I come back to the famous equation, but under the supposition that I have a k in my hand. Okay, this expression. Okay, so the temperature in this case is 50. This is temperature to any time, to the time I need to find. It's equal 30 plus 70, a to the kt. I need to find t, que es t2, time 2, for the condition 2. Okay, now is, let me try, 50, 50, 50, 50, 50, minus 30, 30, 30, get 20. Okay, now this is 70, e to the k t2. Okay, let me put here more intensive. Now you divide by 7 both sides. Cancel out this 0. This is not equal, yeah, already. This is cancel out. There's 2 over 7 is equal e to the k t2. One more time, you apply logarithm of both sides. Similar situation happen. It's a logarithm of 2 over 7, que is less than 1, is equal k t2. Now t2 is natural logarithm of 2 over 7 divided by k. And who is k? This is k. K is natural logarithm of 5 over 7 divided by 5. Okay, you know, when you divide in the denominator, it's exactly the same multiplication as 5 here. Makes sense, right? And after you put in the calculator, please help me with your own calculator. I suppose everyone has calculator. So you put in your own calculator, 5 multiplication, natural logarithm of 2 over 7 divided by another natural logarithm in the bottom of the 5 over 7. And press enter. Wow, fantastic. I get the answer. Let me know what answer you get. And round to the, you know, 1 decimal place. So to the near, is 18.6. Very well. 18.6. 18.6. And what is the unit of this quantity we compute now? What is that? What is that? Jenny says 18.6. Okay, it's important for me. It's important for me. Okay, everyone get your own answer in your own calculator. Jenny is okay, 18.6. That's the answer. 18.6. And what is the unit for this 18.6 watt? Yeah, Edward, you're right. 18.6. And what is the unit? What is the unit? What is the unit of this? 18.6 watt. No idea? Angelo dice, C question. Angelo, C question. What means C question? Time. What is the time? It's time, but in our problem, what is the unit we are using to measure the time in this problem? Come back at the beginning. Minutes. That's the answer. Okay. Also, no problem. You understand very well? Show me. Yeah. Minute. What minute? Minute because any problem, guys, contain different units. Entonces, if you don't change anything, I suppose that everything matching perfectly with the same unit at the beginning. And the beginning was to find the K we use in 5 minutes. So this is decreasing more temperature. Entonces we have more time. Entonces time is expressed in minutes. Make sense or no? Make sense or no? No?
Yes.
Some problem. For example, one problem that we did before. Combine minute, combine days and month. So when okay, you need to express it. Definitely everything to the same unit, no? So yes, day, but month is 30 days. Okay. Do you understand very well the problem? Cooling process, Newton formula. No problema. Any question? Look like complicated or easy? Easy for you or complicated for you? All right, let me see. We have only easy, cool, easy, Jenny. 1, 2, okay, no problem. Gladys, easy. Okay. We have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 students. I am very concerned. Let's see what happened in the test number 3. The student that don't do anything, I drop. Okay, I need to only stay the student that want to pass. The students that are here with me every day. Okay, no problem. Let's go to the one more problem. Christopher, join. Okay. Okay. Do you see whiteboard, right? Let me erase the whiteboard. I have another problem. And immediately I go to the review package. Okay. Wait. Okay, the last problem, number 8. It's different. The last problem is about the logistic model or logistic function, either way. And logistic is a little bit different formula. The logistic is, let me write the formula. And let me explain in what condition you apply logistic. It's a population again. Well, not exactly population. It's, yeah, population. Population at any time is equal capital C divided by 1 plus P e to the KT. So we have 3 parameters, ¿no? 3 parameters. Capital C, o sea, in this case, in this scenario, Okay, let me explain what is the scenario que yo apply logistic, ¿no? On the problem specificate que es logistic, or by the context of the problem you infer que es logistic, because you have a constant population. And normally it's applied to analyze the population of disease. O sea, in this case, it's about the coronavirus. Coronavirus infect the college. I want to read in detail the problem, but focusing on the formula. Now the population is no infinity. It's a number of finite. So we have 1,000 students in this college. Entonces, this is capital Z, is a carrying capacity. Is the technical name of this. Carrying capacity, C. Carry capacity. Carry ing. Carrying capacity. Okay, and this is the students, because the problem talk about the college, no? Okay, and B, ese parámetro que depende somehow the initial condition. Initial, not exactly is equal initial condition, but you can find using initial condition. Conditions. Initial condition. Initial condition, remember, is C null, C0. Initial condition. Remember, we have in the other problem C0, C1, C2, no? Entonces this is C0. That somehow dependent this. And K is a classical K. K is the rate of change. Rate of change of what? Of the exponential. And you have different rate of change, and you have family of the exponential. But this is this exponential is a little bit different. The classical exponential we studied before is like that. Suppose que this is time, this is population, this is uneven growth, look like that. Because you suppose that we have no limitation in the population. However, in the logistic model, no. And why no? Well, first of all, because we have the limited amount of the student or the habitant, human being, and the earth, whatever, and the pandemic is going. However, we have a contradiction. We have two. So the pandemic split the population in two parts. The student gets infected and the student gets not infected. And the rate of change depending of both. So we have one like a horizontal asymptote, you know. And the logistic model when start here and the P null and increasing like that. It's a typical graph of the logistic model, no? And by the way, the rate of change constant again is negative. And this look like contradiction, professor, because when it's positive, it's exponential growth. When it's negative, it's exponential decay. This is classic exponential. But in this case, it's negative. But negative in the denominator is completely different effect. Because negative in the denominator is decreasing, and decreasing denominator increasing the function. So this is an idea, more or less. This is another model to simulate the pandemic. Although not exactly pandemic, is epidemic, no? Because it's local, no it's global. And, yeah, the pandemic is more complicated because depending of the 1/3 possibility is the student or the people who pass the disease and recovery this is included. So we have three variables: student infect or people infect, people health, and people recover. But no, in this case, no, it's easy model. It's only two possibilities: a student infect and a student. Okay. So we have. Let me read the problem again. In the college, which have enrollment of 1,000 students. This is the current capacity. Okay, so this horizontal line is 1,000 students. Population to time. Now, unknownly comes and students with coronavirus. Suppose at the beginning 2020, in China, or here in Miami. On the second days are 6 students, including the student who brought the disease infected. Okay, so this is the time, 6 days. You need to know, okay, time is measured in days in this program. We have 6 students infected. Of course, the scale is no good, but okay, 6 represent student infected in this moment. In the second day. Oh yeah, in the second day, you're right. I am crazy. This is 2 days, and the amount of students infected is 6. This is 6 students. This axis is student, this axis is time in day, 2 day. Let me continue read. Include the student who brought the disease. Okay. The college health authorities organize the type of disease and recognize the type of the disease. Oh, a coronavirus. Okay. And know that if the number of the students exceed 500 patients, the disease become epidemic. I want to avoid epidemic, so I need the vaccinate to treat everyone, isolate the students that are infected. This is a classical approach in epidemic, and in order to control this. So now I need to apply everything, every resource that we have to avoid 500 patients. The disease become epidemic. Using logistic model to simulate the process and determine which is the critical moment to stop the to spread the disease. Okay. Entonces, I know que my formula is this. I know que in our specific example, we have 1,000, 1 plus B, que I don't know who is B, e to the kt. Okay. Now I need to find B first. Okay. B depending of the initial condition. So at t equals 0, at t equals 0 day, how many students we have infected? At t equals 0 days, how many students we have infected? The problem is not clear to explain this, no? Oh yeah. At t equals 0, now, how many students infected? Let me read again the problem. Only one. It's the guy que bring the disease. Okay, entonces, population evaluated in 0 is equal 1 students. This allow me to find the B parameter. Entonces, es equal 1,000, 1 plus B exponential K times 0, because it's T equals 0. Exponential K times 0 is 0, and e to the 0 is 1. So I can delete that part. And you find B. It's easy. You cross multiply maybe 1 plus B multiplied by 1 is 1 plus B equal 1,000. Therefore, B alone is 1,000 minus 1. Okay, 90, 100, 90, 100, 99. So our equation so far is apply condition 0. because the initial condition is 1,000. 1 plus 999 exponential kt. Everyone follow me so far?
Yes.
Okay, entonces I'm using the condition 1, que es this condition. Condition 1 is the condition in which you have, in 2 days, we have 6 students infected, and it's obvious that we have whole information that we need to find the k, because the student is given a 6, so now it's 6 for condition 1, population infected is 6, 1,000, 1 plus 999 e to the k multiplication by 2, que es the time, 2k. Entonces the only unknown that we have is k. Okay, let's do it. You apply cross multiplication or no. Okay, one fantastic way is, you move this like a cross multiplier, but you move 1 plus 999 exponential 2k. I put the coefficients in first. I like this way, not this way. S equal 1,000 divided by 6. No, do you understand the algebra I did that? Okay, you move 6 to here, and this expression I put here because contain the k is the thing I want. So now reduce the lowest term divided by 2 is 500 over 3. Much better, right? Now, I try to solve for k. This is exponential equation, but I need to apply some algebra first of all. For example, I put 999 e to the 2k equal 500 over 3 minus 1. I move this one to the right hand side, subtraction. And 1 is 3 over 3, entonces es basically 500 minus 3, que es 497 over 3. Everyone follow me so far?
Yes.
Now, divide both sides by 999 because I want to isolate the specific exponential. A to the 2k is equal 497 divided by 3 times 999. Okay, I put in my calculator now. Here is 2,997. Oh, important moment. Important moment que you apply logarithm both sides. Okay, I know very well. The logarithm and exponential does each other, and we have 2k equal this. Definitely k is equal logarithm of 497 divided by 2,997 divided by 2. One possibility I explained before is you put in a calculator, you get the decimal approximation, and you store in memory. So you know very well how you are working with the memory. Suppose that you don't know very well how working with the memory, no problema. You leave it like that, like an exact solution, and you plug it in the final answer. And the final answer is now I need to determine in what moment get the condition 2. The condition 2 is the condition in what the health authority predict or need to avoid become like an epidemic. This is 500. So now the time associated with this is 500. 500 students. I need to discover what is the time in which the function p evaluate the specific time 2 is equal 500. Okay, 500 students is equal 1,000 over 1 plus 999 can be e to the kt. Okay, I know it's this. Okay, So let's solve it now for t. My unknown is t2. I need to determine because this DC spread too fast. In one moment, I need to waiting to apply directly, isolate the student, apply bassinet. Okay, now it's easy. Yes, we apply similar idea. You put 1 plus 999 exponential kt, t2, of course, equal 1000 divided by 500 kt2. Cool. Now 999 e to the kt2 is equal to minus 1 because this one I bring to the other side like a minus 1, so 2 minus 1 is 1. So obvious. Now 1, 1, 1, 1. So divide both sides by 999. Okay, so far we have exponential kt2 is equal 1 over 999. Apply logarithm both sides. Nice. And you know that this undoes each other, and it's a kt2 is equal to, say, you divide logarithm of 1 over 999 divided by k. But who is k? K is this expression, que es logarithm of 497 divided by 2997, and these two que is in the bottom I put here in the top. And this is eraser, the up part, and this is the time. Que I need to wait it, que I don't know si es 1 week or es 1 month. I have time to prepare the bassinet and isolate the students. Oh no. Come on, guys, calculate everyone. Yeah, check your answer and my answer. You put in the calculator 2 times natural logarithm of 1 over 999. I suppose que this logarithm give me a negative answer. Divided by another logarithm, again, give me a negative answer because the argument is negative, is less than 1, sorry. Never is negative. Logarithm of 497 divided by 2997. Boom. Close the parenthesis, press enter. Boom, I get the answer. I wait for you. Please try to round to the 2 decimal place. 2 decimal place, I need. Come on, everyone working. Guys, I am supposing. Wow, so it's still left. Oh, unbelievable. Here's the answer. Here's the answer. 7.69. That worked. See, the answer is cool. The answer is 7.69. Cool. 7.69 what? Where's the unit of this? Days. So actually, to be conservative, we need 1 week to apply the bassinet and isolate the students. Well, it's 1 week and a little bit more. No 8 days, 7 days. Que es a week. Do you understand very well this problem or no? So basically, we have 4 kind of problem. We have the number 1 problem is of course, we have another problem of the finance compound interest, but in the science, we have four kind of problem, no? We have the 3 and 4. We have the exponential growth, exponential growth, look like that. Okay, entonces now the formula is population at any time is P null, que P null represent the population at t equals 0, P null, e to the kt. And k is always the rate of change. Okay, however, k is positive, always in that case. We have another kind of problem, que is exponential decay. Exponential decay, the formula is, you know, remember, it's the test of carbon 14. Amount of substance to any time is equal A null e to the kt. And exponential is different. It is A null, the amount of substance that normally is expressed in relative unit, 100%, and decrease like that. And in this case, k is negative. And the reason k is negative is clear because it's decreasing. Another problem that we have is a Newton cooling process. A Newton cooling, I suppose that we have one temperature initial, Ti, and we have another temperature final. Always temperature initial is bigger than temperature final because it's cooling. No? And you know, it's similar to this, but the problem is that the temperature decreasing to the final temperature, the temperature of the room environment. And the formula for the Newton say temperature to any time is equal to temperature final plus subtraction temperature initial minus temperature final e to the kt. Okay. It's a formula for the Newton. In this case, k is negative again because it's decreasing. And finally, the logistic model. The formula is a little bit different. Is population maybe at any time is equal to C, que is the carrying capacity, 1 plus B e to the kt. And thus in this case, unbelievable, k is negative again, but however the function is not increasing, it's not decreasing, it's increasing. This is P null, and this is the carrying capacity que represent like a one horizontal asymptote, no? And look like that. Oh, like that. Carrying capacity. Pardon, I make mistake here. Too much. This is P null, and this is the carrying capacity. The logistic model, sorry, logistic model. Clear? Any question about this word problem? This is the application, guys. There are more applications, but I decide to explain this kind of application, no? For the exponential, because we ending always in exponential equation or logarithmic equation, no? May I erase the board?
Yes.
Okay, so we start review. I don't know if I want to make a screenshot. Yeah, let's do it. A screenshot. Let me try. You have a package. You can open. You see problem by problem. We have today and so this entire week doing this, right? Let me try. Let me see. Okay, review. Okay, I want to make screenshot page by page. screenshot, because the screenshot is the way it allows me to put in the whiteboard. Let me try. This is the. There you go. Okay. I do it one by one. This is the review. Page 1. I save. Let me see so I can get directly in the whiteboard. Image, device. There you go. Do you see my whiteboard now? Can you see the page number 1 in the review? Yes or no? Yes. No, Edward. We start at the beginning. Okay, what is the beginning? The beginning is the inverse function. Okay. You need to determine if the function is 1-to-1 or no, and write the inverse function. Okay, I understand. And the question number 1 say f of x is equal 9 minus x divided by 5. Let me try to find the decimals. Can I create the graphic of this? Okay. Okay, decimals. Okay. Inverse function. There you go. I have that. Okay, no problem. This is one. No, sorry. It's a review. Review test 3, no? Oh yeah, there you go. I got it. Super. I have the graph. Okay. Don't worry for this. Question number 1. What do you think about this function? This function is 1-to-1, yes or no? How do you know that? How do you know? See, one function is 1-to-1. What is the fantastic test? Okay, we have to find the 1-to-1. Come on, help me. Nobody know? Nobody? Eh? Horizontal line test. Very well. And what do you think about this? Pass the test or fail the test? I need to do the graph. Yes, I need to do the graph. However, you see what look like the graph of this when you see that or no? It's clear or confused? 9 minus x over 5. What is that? No, don't do that. You see, I suppose that you, my question is, I suppose that you recognize immediately the graph of this function, no? No? You don't know? So we need to use decimals. Or no? Come on, guys, help me say something, no? Come on. Who help me? Edward. Gladys. Jenny. Is the student can more participate? What kind of graph it is? Es parábola, es linear, es linear, es obvio. Easy. But we can use in Desmos. Of course, we can use Desmos anytime. Desmos is our fantastic calculator. Desmos is our fantastic. I want to show you, but not now. If you want to open anytime Desmos, and you see the graph, it's linear. It's a line. Yes or no? Makes sense? And when you apply in one line, the horizontal line test, pass or fail? Pass. Therefore, it's 1 to 1. Therefore, we can find the inverse function. To find the inverse function, you replace f of x for y. Now, important moment, interchange x for y. Now, in order to find the explicit way, the explicit form, you isolate the y, get the new y, and this new y is inverse function. You cross multiply 5x is equal 9 minus y. Therefore, I move y here to the other side is y positive is equal 9 minus 5x. Wow, is this? Cool? Okay, pero no. I want to see graphically in Desmos. Okay, I want to make sure, okay, I'm doing well. Then I recommend you go to Desmos. There you go. Do you see Desmos now?
Yes.
Question 1, look at that. Question 1 is this. Okay, in blue color, blue color, you see the given original line function que es line. Okay, I determine algebraically in the piece of paper the inverse function is this. Boom, green color inverse function. And this is symmetry with respect the line y equal x. Do you see that? Clear? This is a confirmation everything is okay. However, another way, suppose I have no Desmos or I don't want to use in Desmos or the way you prefer. Well. We are doing something. We are doing in the whiteboard. We're checking. How we checking? Well, we put together, for example, I put together, let me try, put together F, que es the original F, composition inverse. And who is the inverse? The inverse is this. And likewise, why not? In the opposite direction, no? Inverse function, composition F. And I suppose, hypothetically, because if we are doing well, we get the identity. I suppose. Let's do it in that direction. I replace this case inverse here into this. So we have 9 minus no x anymore. No, I replace by 9 minus 5x divided by 5. Well, you remove the parentheses, 9 minus 9 plus 5x divided by 5, no? This is cancelled, 0. And 5x divided by 5 is x. Case identity. Likewise, see you using, let me use a different color, that one, and use substitution here, que es f first Remember, in the composition, we have two functions. The first function is the innermost. Go completely to the outermost. So basically is 9 minus 5 parentheses. Entonces, you replace x for this is 9 minus x over 5. Wow, easy. 5 cancel. Stay only 9 minus 9. So this is distributed product plus x. 9 is cancelled, subtraction 0. Again is x. This is another way to see. Everyone follow me? Come on, come on. Question, opinion. Clear, super easy, complicated, I don't understand anything. Sí. Okay. Okay, cool. Cool, cool, cool. Okay, let's move on to number 2. And we're doing everything you want. So you see the graph, you see the graph. Well, not necessarily. The question don't say anything about graph. So my second question is a function f of x equal cubic root of x minus a. I need to find the inverse. What do you think is one to one or no? I have no idea. This belongs in this subject. We are working with the classical functions. Okay, you need to know the parabola, the cubic parabola, the so the parabola is x squared, no, like that, x squared. The cubic parabola is like that, cubic. The square root is something like that. Okay, by the way, the domain is only positive, no negative. And the cubic root can look like that. Similar, but both directions. It's a cubic root. Approximately, you know, it's the shape. It's the shape. So what is the connection between this guy and this guy? Belong to the same family or not? Belong to the same family or not? Yes. Yeah. What is the only transformation that you can see? What is the only transformation that you can see? Minus A. It will say A unit to the right. It's horizontal shift, A unit to the right. Super, Edward. Okay, but does now this function, when you apply the horizontal line test, pass or fail? Is A to the right. Cool, because it's minus. I understand very well.
Pass.
Pass. Pass the test. Okay, just in case, si you don't know, you don't remember, you put in the Desmos and you verify in Desmos. Pero bueno, I want to practice a little bit transformation, you know. Okay, so now the rest is easy. You replace f of x for y because this is the same thing. There's two different ways to express the same idea. And interchange x and y. This is the most important part. When you are doing this is x. And this is y. Actually, in this moment, don't. This is the inverse function. But what is the only problem? It's expressed implicit. Implicit is not useless. It's totally useless. I need to express an explicit. Explicit is when the y is isolated. To isolate the y, well, I propose you cubic both sides because I want to destroy this cubic root. We have x cubic, and you know very, very well that cubic root and cubic power together endose each other. Now, x cubic plus a is equal y, and this new y is the inverse function. Cool? Asked by curiosity. A ver, es b, ¿no? Es b. Es b, es b. Es plus. Es b. asked by curiosity, you can see the graph in Desmos, or why not, by curiosity, let's check it by the composition of F composition F inversa or F inversa composition F. What way you prefer in the test? You apply the composition to discover the composition its identity, or you prefer doing in Desmos? What do you consider better, in your opinion? I want to hear opinion, no? Desmos. Jenny said that Desmos much better, professor. Okay. I respect. Remember, we are living in the United States of America. We are living in the 21st century. And 10 years ago, no, it's different. The student need to do a lot of things, well, using calculator, but the calculator you have in your hand. Now you have calculator on internet. You have graphic calculator, fantastic graphic calculator in 2 dimensions and in 3 dimensions. You study Calc 3 with me, then you see how you graph it in 3D. Okay, so you prefer Desmos? Okay, let's do it both way. Suppose now, okay, I switching. I share the screen of the Desmos. ¿Qué es this? You see that? No. Yeah. Okay. Cool. Question 2 is look at that. I copy here the original given function and the inverse function, and when I graph it both, look. Whoa. The red one is exactly we predict. Okay, is the cubic root function. Okay, normally the basic function start in 0, 0, but in this case we have translate a unit to the right. Cool. And the inverse function is a cubic, and cubic is translated a unit over because the vertical shift. Horizontal shift and the red one, vertical shift and the blue one. And you see that these graphics are perfectly symmetric with respect to the line y equals x. And this is the strong verification that they are inverse each other. Any question? What part you don't understand? Clear? Clear. Suppose that another student say, no. I don't like this way. Why I don't feel strong in that way. I prefer doing by hand in the composition. Okay, let's do it. In this case, is inverse function is this. This is this. Inside here, I replace x for this. So is cubic root. I copy the outermost cubic root and replace x for x cubic plus a minus a. Do you understand what are you doing? So this is this. This minus a is this minus a. Positive a and negative a cancel out, and stay cubic root x cubic is x. Is identity. Now let's do it in the opposite direction. In the opposite direction, using red color maybe. And now my goal is this substitution here. So basically it's open parentheses, and you put cubic root x minus a raised to the third power. This third power is this third power plus a. Okay, this is cancel and stay x minus a plus a. And these three cancel. Positive and negative is 0 and it's identity. Do you follow me? Okay, Jenny. Guys, I appreciate so much the participation. I know the name of the student that participate, and these students have the privilege because you are in the border between A and B. For the participation, I get automatic A. Because you are a student that go to the same path of me and help me a little bit. Okay, number 3 is f of x equal 5x cubed minus 7. This belong to the family of the cubic function. So look like that, no? Cubic function, yes or no? Well, the problem is that you have multiplication by 5. So this multiplication by 5 is only a vertical stretch, 5 unit, 5 unit. So by the factor 5, no? It's a vertical stretch. Can pull upward and downward, no? And deformation a little bit. I suppose que multiplication, suppose it's something like that. Multiplication by 5. No, I make it too exaggeration. This is like that. And minus 7 is going down. So this is the vertical stretch, no? Factor 5. With the factor 5. With the factor 5. We have factor 5. And minus 7 is vertical shift. 7 unit down. Make sense? Do you understand
Yes.
very well? Do you understand very well vertical shift, factor 5, or no? What is the effect in the curve? Do you understand? Honestly, you understand or no? Yes or no? Help me. Yes, I understand. Okay. Okay, so my next question is, this function is one-to-one or no? When you apply the horizontal line test, pass or fail? Pass. It's obvious, right? Okay, the procedure is the same. You have y equal 5x cubed minus 7. Now interchange. X equal 5y cubed minus 7. Now solve for y. X plus 7 divided by 5 equal y cubed. Apply cubic root both sides because my goal is y alone. And this is the new y can represent the inverse function. Now let me see. Is the option B, no? B again. B again. Entonces, how you prove que the thing that we're doing is okay? Remember, we have two possibilities, no? Do the graph in Desmos or apply the composition and undo each other and give me identity. What do you propose me, right? Desmos again or Desmos again, Jenny? What? Okay, I respect Jenny because Jenny is good student. Okay, there you go. Okay, let's go to the Desmos window. Do you see or no? Okay, I copy Okay, I copy. Okay, I copy the original. I copy is inverse. Look, the red one is the original. It's obvious. It's a cubic function, the same shape, but vertical stretch. And 5 units down. Now the inverse is this. And you see, you prove ahí geometrically clear, symmetric with respect to the line, y equal x. End story. Do you want I do by hand or no? No? Oh, yes. Yes, we need to practice, no? It's a review. It's a review. We need to be strong. After that, the student can pay attention, participate, and do the homework online. Have 100 points for sure. I guarantee you. Now, if you are lazy, entonces I understand que you don't pass. Okay. Whiteboard. You see whiteboard? As always.
Yes.
Okay, we are doing now F composition F inverse. F inverse composition F. What mean composition? You take, for example, this function. Oh, you take this function and you replay here. So I copy in this order. The outermost function is F. I copy this 5, is this 5. You replace x4 cubic root of x plus 7 over 5. And you raise to the cubic power and subtract this. You need to prove that this is the identity. Okay. The first thing I can see can cancel out is cubic and cubic. And we have 5 times x plus 7 over 5 without cubic root. And 5 minus 7, sorry. And 5 cancel. And stay now x plus 7 minus 7 again is cancelled. You know how little by little the functions is on dos, on dos, on dos, on dos, on dos, on dos. Now in the other order, using green color, the idea is you take this guy, substitution completed here into the x of the inverse. Okay, entonces es cubic root of no x anymore, no, it's 5 x cubic minus 7 plus 7 over 5. The thing I am doing is this part represent the x part and the original, no? I replace this x for this. Es obvio, es obvio, es obvio. Es obvio. Es obvio que this 7 cancel out. Let's take cubic root of 5x cubic over 5. Oh, again cancel out. And we have finally cubic root x cubic is x again. Super, super clear. No question? No? Yes? Oui. Okay, let's go what number is? Number 4. Number 4 look like complicated. Number 4 is f of x is equal x plus 5 divided by x minus 1. It's a rational function. It's a rational function. Okay, entonces you replace f of x for y. And you interchange x and y. That's what we have. You want to find the inverse. I forgot to say, is it 1-to-1 or no? What do you think? Well, in this case, I need to go to decimal to verify that. It's a rational function, no? Let me try to, suppose que I am in the jungle without internet and without decimals, no? What do you think about this function? This function has horizontal, vertical asymptote. At what value we have vertical asymptote? This function.
At x equals 1.
At x equal 1. Very well. So at x equal 1, here, we have vertical asymptote. And horizontal asymptote we have or no? No? Horizontal, no? You don't remember horizontal asymptote? What is the analysis of the degree that you should do? Okay, yes, everybody say yes. Yes, what? We have horizontal, yes. At what value? At what equals something? Yes. Okay, the answer is 1. So we have one horizontal asymptote here in 1. This is 1, this is 1. It's a coincidence. And this is similar, very, very similar to the graph. Okay, this belong to the family of the function. Okay, you very well know. ¿Qué es el reciprocal? Reciprocal function. A reciprocal function, the graph look like that. And the equation is 1 over x. However, this is more than this because we have horizontal and vertical, but the shape is the same. Look. Approximately, this is the graph of this function. Entonces my question is, when you apply the horizontal line test, pass or fail? Es obvio que pasa. Es obvio que pasa. Therefore, we can do the inverse. We can find the inverse. So the inverse exists. The inverse exists. Therefore, ready to find. You put it here, x, y plus 5 divided by y minus 5. Remember, you interchange x and y, but in order to find the formula for the inverse is you solve for y, but it's easy. You apply cross multiply like that, boom, boom. So says x times y minus 5 is equal 1 times y plus 5. You apply distributive property xy minus 5x is equal y plus 5. If you want to solve for y, you put a y in the same side, maybe in the left, minus y is equal 5 plus 5x. You factor out y, and finally divided by x minus 1 both sides. The answer then is y equal 5 plus 5x divided by x minus 1.
Professor, shouldn't the denominator be y negative 1 instead of y negative 5?
A ver, ya make a mistake, right? Yeah, This,
Yeah.
yeah. Okay, you multiply this and multiply this, no? I did well? Yeah, what's the x? I did it well. So you multiply. Wait. Okay, let's do it again. Because I don't see the mistake. No? When I see don't see the mistake, I erase everything. You start at the beginning. Okay, this is x equal y plus 5 over y minus 1. I did okay?
Yes.
So you cross multiply. Is x times y minus x. I did okay? Equal y plus 5. I did okay?
Yeah, the error the first time was that it was y -5 in the denominator.
Oh, no x.
Yeah.
Hello. Okay, now xy minus y is equal x plus 5. Factor out y, x minus 1, x plus 5. So we have y alone is equal x plus 5 divided by x minus 1. And this is a new y, que es exactly the inverse function. Okay. Notice que in this new function, let me try to investigate by curiosity what is the vertical asymptote and the horizontal asymptote in this function, in the new one, in the inverse function. What do you think about the vertical asymptote? At what value is the vertical asymptote? Is at x equal 1. Okay, you take the denominator part equal to 0. And the horizontal asymptote? And the horizontal asymptote is again in 1, no? In 1, no? Or no? But in this case, it's a coincidence. Yeah, because in the original is 1 in both cases. This is when you interchange, because the important information is que the vertical asymptote and the inverse are corresponding with the horizontal. This one actually is this one. And this one actually is this one. It's a coincidence that everything is one because it is nice. I want to see in Desmos now to understand much better. Okay, and after, if you want, let's do in the confirmation to say what the answer can you select. I suppose que the answer is A. Yes or no? It's a little bit weird because they put 1x plus 5 divided by x minus 1. Okay, let's do in the confirmation and demo, no? Okay. Because Desmos confirmed that, however, allow me to understand a little bit the asymptote. Okay, you go. It's a question 4, no? Okay, wow. Wow. Look at that. Something interesting, and we are happy in this example. Super interesting. I copy in black color the original function. Y I copy in red color the inverse function. And you know that they are identical. Yes or no? Okay, this is not the only unique function that satisfies this. Any function that is symmetric with the line y equal x happen that the inverse function is exactly the same of the original function. There are several examples, not only this, but this is a good example to illustrate very well this idea. Do you see that? Cool, eh?
Yes.
Yeah. There are no infinity scenario, but there are a lot of functions que satisfy this. Okay. Suppose I want to verify algebraically. To make sure that you say, I detecting, wow, something is weird, something is confusing, it's the same. Wow, why? There are some special. Okay. Now, I want to confirm it using the composition. So composition, F inverse, and F inverse composition F. So in this scenario, you replace that one, get inverse function here and here. Wow, in two places. Okay, so now we have x plus 5 over x minus 1 plus 5, x plus 5 over x minus 1 minus 1. Do you see the idea? Basically, the thing I did was this substitution here and here. And let's see what happened. I don't have idea. You find the least common denominator is find the least common denominator is x minus 1. So suppose I try to the LCD is x minus 1 because it's the only expression we have in the denominator. It's x plus 5 times x minus 1, something like that. But no, we continue. Why not? Doing the numerator part. I forgot for a moment denominator part. Okay, so now we have x minus 1, x plus 5, plus 5x minus 5. Distributed here, no? Oh, at least that part cancel. Okay, and you adding, this is 5 plus 1 is 6 over x minus. And for a moment, stop, leave it like that. We go to the denominator part. It's similar. The LCD is x minus 1, is x plus 5, minus x minus 1. This minus, of course, involve everything. So now in the second part, we copy x plus 5 minus x plus 1. This is cancelled, and 5 plus 1 is 6 over x minus 1. Oh, finally, we have division, complex division, and you copy the top part exactly the same. Multiplication, reciprocal, bottom part, I flip that. X minus 1 is cancelled, and 6 is cancelled, and stay only alive x. It's a strong proof that we are doing well. And this is a confirmation, no? It's a confirmation. Now, let's do it in the opposite direction. And the opposite direction is that one. Red color. But they're similar, no? Because they are identical. It's the same job. So we need here. What do you think? We need to do again or no? Because that's identical. It's a coincidence. So it's the same job. Same. The same job. Give me the same answer, no? Sound good? Sound beautiful? Sound good?
Yes.
Okay. Let's move on to the second page of the review package. I need to make another screenshot. Let me see. I have here or no? I need to open. I need to open. I need to open. I need to open. Okay. Okay. Review, second page. Okay, I did the first page. Now the second page. Oh, it's easy. I remember I did this job. I'm a little bit crazy, guys. Okay, this is snipping tools. Using a snipping tool to make a screenshot. Oh no. Snipping tools. And you save that. Okay, I put page number 2. Page number 2. Okay, cool. And now I go to the whiteboard. Okay, I bring this page like an image. Okay, okay, this is the it's giving graph, and it's giving the function, and you need to match. You need to match. You need to match. Okay, the function gets given is exponential, right? It's f of x equal 7x. Okay, so we know, okay, we have two kinds of the exponential. We have exponential growth and exponential decay, no? This is exponential growth, and this is exponential decay. By the way, any exponential, we make a mistake. Every exponential passing through the famous point was 0,1, and the idea is growth or is decay depending of the base. The base is 7. And since 7 is a number greater than 1, so it's growth. It's like that. This is obvious. Okay, look in this. You discard this possibility and this possibility, no? It's stupid, right? So maybe a C or D. However, I look in the domain and look in the range. And you need to know perfectly that the domain of the any exponential is all real number. The domain of the exponential is all real number. And the range, no. It's from 0 to infinity. So baby is the option C. Is correct or no? Option C. Yes. So it's the same graph, but you select the option correct. However, in the test, no. The test no multiple choice. In the test, you need to show in detail the word and the correct word and clear. Some student the last test doing, something like that. I don't understand anything, 0. Okay, 0. And copy only the final answer. No. You need to show your word anytime. Any question? Matching, exponential, and graphic. The clue is the base is 7. 7 is a number bigger than 1. We are in front of exponential growth. Exponential function get increasing, not decreasing. Of course, we are talking about increasing or decreasing from left to right. No? Okay, let me try to, sorry for the delay. Let me try to make a screenshot of the page 6, 7, and 8 to make easy. And you help me to understand this. Okay, again. This is, okay, this is not the number 6. Let me try to make a screenshot quickly. Snipping tools. Okay, cool. Save as page 3. 3. Cool. Now, page 4. Snipping tool again. Save. Page 4. Page 4. Cool. One more. Page 5. Page 5. Okay. Page 5. Okay. Make it the zoom. See the page full page. Cool. Now snipping tool. Okay. I suppose I did this job. Well, I don't remember. See, I save, maybe no. Okay, say as. This is page 5. Okay, there you go. Okay, ready. We are ready. Okay, I come back to the whiteboard. Do you see whiteboard or no?
Yes.
Okay, so we have page 3, 4, and 5. 3, 4. But don't worry, one by one. I need help. You help me to identification, matching exponential and the formula. Wow, 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 what the hell? Okay, in this number 6 question, the most important is identification. What's the base? What is the base of this exponential? 2 over 7, cool. And 2 over 7 is greater than 1 or less than 1? Yeah, 2 over 7, cool. This is less than 1 or greater than 1? 2 over 7.
Less.
Less than 1. Entonces, Jenny say it's decreasing, professor. Decreasing. Decreasing. Okay, or another name that we use in decay, no? Exponential decay. Okay, sinónimo, you know, it's the same idea. So decreasing is the only, well, this is wrong, and this is wrong, no? Because this is increasing, right? So we need to determine si es the option A or option C. What do you think? Same idea, no? So, is C because C domain is all real number and the range is only positive. So do you understand very well that any exponential, doesn't matter if it's decreasing or increasing. This is a famous point, 0.1. The domain is all real number. This is the positive part and this is the negative part. This is the domain. And the range, no. The range is only the positive part. It's from 0 to infinity, and don't touch 0 because it's asymptotically, no? To 0. Eso es obvio que es de option C. Any question? What part is confusing? What part you don't understand? Clear? Moving on to question 7. We continue analyzing exponential. Oh, this exponential is f of x equal to x plus 1 minus 4. Okay, the base is 2. And 2 is greater than 1. Therefore, it's increasing, no? So my exponential look like that. 1. Never like that. Never down. Oh, but every option that we have is increasing. Oh, this is not a clue to differentiate that. However, the most important thing is this minus 4. What represents this minus 4? 4 unit down, 4 unit down, 4 unit down. And this represents the horizontal asymptote because normally the exponential function have horizontal asymptote at y equals 0. But in this specific example, it's not 0, it's negative 4. So when the exponential is going to 0, que es el negative infinity, the horizontal asymptote is negative 4. And negative 4, let me see, is this? This no, because it's positive 4. This is positive 1, and this is negative 1. Look like, however, I want to see more. I see here 1 point. I see here 1 point. 1 point. Let me see at least the x in a set and the y in a set, at least. Okay, super important point to help me do identification. I am for sure get this, but suppose I want to evaluate the function in 0. The function in 0 give me an idea about the y-intercept. So this is y-intercept point. You know the formula. And you evaluate in 0, entonces 2, 0 plus 1, minus 4. 0 plus 1 is 1, and 2, 1 power is 2, and 2 minus 4 is negative 2. So this famous point would be 0, negative 2. Let me see if it's good or not. 0, negative 2. Oh, yes, look at that. This is the point 0, negative 2. Look. This point is 0, negative 2. Almost confirmation. Almost confirmation. Now, let me try to find the confusing this point. I have no idea. Look like 1 point something. How you determine that? Well, not exactly the same we are doing before. Suppose que you want to find the x-intercept. And the x-intercept is when the function is 0. Now, what is the function? The function is this. The function is this. So you take the original function, que is 2x plus 1 minus 4. You enforce it to be 0. You enforce it to be 0. And you solving this exponential equation. Entonces es 2x plus 1 equal 4, no? My goal is solve for x. I know that it's possible doing put the common base because 4 is 2 to the second power. If we have two exponential and exponential have the same base, it's because the exponent are equal each other. X plus 1 equal 2, therefore it's 2 minus 1 que es 1. Wow, fantastic. And the point is the point 1, 0. We predict at the beginning que no 1, but yes, mathematically prove that. This point is the point 1, 0. Yeah. Makes sense? At this
Yes.
point, let me erase that part. This point I have no idea. Now I have perfect idea. It's the point 1, 0. It's a confirmation to make sure. Actually, I don't need to do this because by the horizontal asymptote, I differentiate perfectly. It's the option A. Do you want? No. En Desmono. Yes or no? What do you think is necessary or no? No. Cool. Yeah. Let's move on to the next page. Next page. Who is that? Okay. Uh-huh. No. Segue dice no, no. No necessarily. Okay, okay. This is exponential. But, confusing. Because the function is minus 3 raised to the x power, no? Now the base is obvious 3, no minus 3. Be careful, the base never is negative, by definition. So if you have base, you try to create one function that the base is negative, it's not exponential. Exponential by definition, this negative you can interpret it like a reflection. So we have our famous exponential like that, like in 3 to the x. But you are doing reflection about x-axis. So this exponential look like that, minus 3 to the x, because this minus is like, you know, the x value stays the same, but the y value no, it's changed the sign, it's opposite sign, it's negative. So in my opinion, this is totally wrong. Help me, guy. Bueno, see, this is totally wrong. And this is no. I suppose que, yeah, it's B. It's obvious, right? It's B. This is correct. Why not this? Why not? Because this is when the base is less than 1, decay. And this is similar but with reflection. As you reflecting this, look like that. So in this case, the base is less than 1. In this case, the base is less than 1, but we have extra negative in the front. Okay, maybe it's base 1 and reflection. In this case, nice because the base is bigger than 1, is 3, bigger than 1, and we have reflection. Reflection across or above x-axis. Super cool.
Yes.
Let's do number 9. Number 9 is relatively easy, but I want to analyze everything in detail in a piece of paper, and after we see in Desmos. Using the graph of the y, so you start doing the graph of the 1/2 raised to the x. This is the base, and this is the family of this. Because f of x equal 1/2 x plus 4 minus 3. How many transformation and what kind of transformation you can see in this new function? How many and what kind of transformation? How many transformations? How many first? Compare the basic and the new one. It's a family. It's 3 down. Yes, you are right. 3 down. These 3 indicate us. Vertical shift. 3 unit down. And what more transformation you see? One more. One more. Plus 4, no? And what is plus 4? Nobody know? Nobody know? Edward, Claudia, Jenny. Es 4 to the left. Es horizontal shift, ¿no? Now let me see. 4 to the left. Okay, Jenny say this is 4 indicate horizontal shift. Four unit to the left because it's positive. Okay. And this basic function is exponential growth or exponential decay. So this is like that or it's like that. This the base is decay. Is this. So I need to modify. Let's do it now. To modify, we have the horizontal asymptote. Of course, I am doing decimal, but to have roughly idea, let me try to find in this folder, another folder. Let's see here. Okay, there you go. No, this is not this one. Rectangular coordinate system. Suppose that this is my rectangular coordinate system. Suppose that I am doing no in decimals. I am doing what the hell? Okay, again. Rectangular coordinate system. Okay, enlarge. Okay. So basically, I am doing the graph of f of x equal 1/2 raised to the x plus 4 minus 3. This minus 3 represents the horizontal at y equal minus 3. So normally we have horizontal 0 degree here at minus 3. This is the horizontal. What happened with the equal sign? Equal sign. But to make a decent graph, it's obvious that the domain in any exponential is a real number, no problem. Because the exponential function is a nice function asset. However, the range, no. The range normally in the base is from 0 to infinity. But in this case, no, because you subtract this. You subtract it to says from -3 to infinity positive. So we have exponential in that part. And below the asymptote, the horizontal, and we have no more. So you have roughly idea. Let's try to find the y-intercept. Y-intercept is evaluate the function in 0. Evaluate the function in 0 is 1/2 raised to the 0 plus 4 minus 3. Okay, no problem. I understand. Is 0 plus 4 is 4. Entonces 1/2 raised to the 4 power is 1/16, no? Minus 3. Basically is least common denominator is 16. We have 1 minus 36, no? 36. 38, no, 40, 48. 16 times 48. 16 times 3 is obviously 48. And 1 minus 48 is 47. It's negative 47 over 16, but I am confusing. This is approximately in decimal, negative 2 point something, negative 2.938. Wow, close to 3. So now this curve closes the y-axis very close to 3. Okay, at the point, negative 2 points, our famous point is the point 0, minus 2.938. That block that point. Okay, this is the y-intercept. And what about the x-intercept? Let me try. The x-intercept is x-intercept. X-intercept is you take the function and you enforce it to be 0. This is the x-intercept formula, no? And you take 1/2 raised to the x plus 4 minus 3 equal to 0. And we have 1/2 x plus 4 equal 3. Unfortunately, in this case, we cannot apply the idea of the same base. So you necessarily, you need to apply logarithm. What kind? Well, standard. Standard because definitely we ending in calculator. You apply logarithm both sides. You apply one more time the property number 7. Property number 7 is fantastic. Allow me this exponent go to the front like a factor. And logarithm of 1/2 equal logarithm of 3. Okay, now distributed. This is now it's not exponential equation anymore. This is now linear equation because logarithm of 1/2 and logarithm of 3 is just a number. It's a weird number, I understand, but it's a number. Okay, we can put it in a calculator anytime you need. Now x plus 4 along is equal ln 3 divided by ln of 1/2. You can put it in a calculator like that. Or no. Yeah, why not? Okay, you put in a calculator. You put x is equal minus 4 plus natural logarithm of 3 divided by natural logarithm of 1/2. Okay, let me try see I did well or no. Let me try see I did well. I put in a calculator because I copy weird here. Negative 4 plus. Obviously, look at that. No, obviously, that part I predict is negative. Because logarithm 3 is positive, pero logarithm 1/2 is negative. Remember, any logarithm, of course, standard, no? Of the number less than 1, give me negative number. So it's actually negative 4 minus 4. And okay, it's the answer, yes, you're right. It's negative 5.585, no? 49, okay, I round, but it's okay, much better, 49. 49. Okay, entonces our famous point is, wow, it's a point negative 5.5849,0. And crazy, 0. Okay, it's on the x-axis. It's almost here, over there. I suppose, no? 5.59, approximately here. And this exponential is decay, no? It's decay. It's decay. Yeah. Okay, entonces this exponential look like that? I suppose, no? Or no?
Yes.
Okay. To make sure, let's do it in this one, eh? We have technology. Hello. Let me try to see that more clear. And that's it for today. Okay. Stay here. Oh, what happened with Desmos? Desmos here. Desmos. Okay, share to Desmos. There you go. Okay, no. Do you see Desmos?
Yes.
This is question number 9. Question number 9. Oh, look at that. I put a question like that. 1/2. I determine a several point. I determine, guys, the y in a set que was that guy, 0, -47 over 16. Do you remember that, right? This guy, look, when they cross the y-axis. I determined the x in a set que was -5.58 something, no? Okay, cool. And I determined the classical typical point, I determined the piece of paper, que is +1 and -1. You evaluate the function at +1 and -1. This is the three typical point que is important in any exponential. Plugging in 0, plugging in 1, and plugging in -1. And the other is complementary, no? The other is the x in a set was cool, perfect. And the famous horizontal asymptote, que is at y equal -3. You see que the exponential approach, pero never touch. Look, let me show you. Always travel close, pero above the line. Do you understand very well?
Yes.
So for today is enough. We continue Wednesday this super review. Okay, to be ready for the test. Okay? Okay, guys, I enjoy too much. What happened with the camera? Do you see my face now?
Yes.
Okay, bye-bye. Take care.
Bye, Professor.
Have a nice day.